What if the flow of time, past, present, future, is all just an illusion? A brand new scientific framework is suggesting it just might be. And get this, the proof isn't in some far-off galaxy or a giant particle accelerator. Nope, it's right here on Earth, hidden in the 66-million-year-old dust from the asteroid that killed the dinosaurs. So how on Earth can an ancient rock tell us that time might not even be real? Let's dig in.
So the core idea here is trying to tackle one of the biggest puzzles in physics, this huge disconnect between how the universe works at massive scales and how it works down in the tiny quantum world. This theory, it's called TCGS-SEQUENTION, and it proposes that everything we see, everything we experience in our three-dimensional world is just a projection, kind of like a shadow that's being cast from a higher four-dimensional reality, a reality where our whole concept of time just doesn't exist.
Okay, so what does that actually mean? Let's break that down. Think of it like an old-school movie projector. You've got the entire film reel, right? Every single frame from the beginning of the movie to the very end, it all exists at the same time, sitting there on the reel. That complete reel, that's the 4D source. Our experience of now is just the one single frame that's being lit up and projected onto the screen. The past and the future, they're just other frames on that same reel. They're not gone, they're not yet to come, they just are.
But, for a wild idea like this to be actual science, it needs evidence. You can't just make stuff up. And amazingly, the clues might be buried deep in geology. So, we're going to look at two totally independent pieces of evidence from Earth's own history that both seem to point to the same very strange conclusion.
All right, pillar number one. This comes from one single, unbelievably catastrophic moment in Earth's history, the Chicxulub impact, 66 million years ago. Scientists went back and analyzed the dust from that event, and they found something that could be a genuine fingerprint of that higher 4D reality.
But here's the tricky part. If our world is just a shadow, how can you tell what's a real feature of the objects casting the shadow versus what's just a weird distortion created by the light and the angle, by the process of projection itself? This has been the central challenge for this whole theory.
The way they cracked it was by looking for two totally different kinds of signatures in the exact same place. First, they needed what's called a slice invariant, basically a property of the raw ingredients that doesn't change no matter what happens. Think of it as the recipe list for a cake. And second, they needed a foliation-dependent artifact, a signature that's created by the process itself. So not the recipe, but the final texture of the cake after you've actually baked it.
And they've found it. It's incredible. By analyzing these really special isotopes, elements that were forged in distant stars and don't get messed up by the insane heat of an asteroid impact, they could isolate the original recipe. And they found this fixed, unchanging number. No matter what happened during the fiery explosion, 17 to 25% of the dust came directly from the asteroid. That's it. That's our slice invariant. It's a pure signal from the source.
Then they found the second signature. A different isotope, magnesium-25, told a completely different story. It was all about the process. See, its final signature was completely dependent on how the superheated cloud of vaporized rock cooled and expanded over time. If it had cooled just a little bit faster or slower, you would have gotten a different number. So this signature was literally created by the history of the event, making it the perfect fingerprint of the 3D shadow.
Okay, so this is where it gets a little wild. What does this 4D source actually look like, according to the theory? Well, the model has this really complex name, a gravitocapillary foam. But the idea behind it is surprisingly simple. Just imagine a vast, four-dimensional structure made of something like soap bubbles, where the surfaces, the films of the bubbles, are all shaped by a kind of gravity.
And this is where the abstract theory and the hard evidence just collide, and it's brilliant. The model predicts that the shadow of this 4D foam should look like, well, a shadow foam. So what did the Chicxulub impact actually create? A pyrocloud, a turbulent, swirling cloud of molten droplets. It's a literal physical foam. It's an almost perfect match between the weird abstract theory and the actual physical evidence.
Okay, so that's the evidence from a single fiery moment. It's pretty compelling stuff. But for a theory this huge, you're going to need more than that. So now, let's zoom out. Like way out, from one instant in time to the entire 4.6 billion year history of planet Earth, to look for a hidden pattern in the very fabric of time itself.
Yeah, we've all seen this before, right? The geological timescale with its eons and eras and periods marking all the major events in Earth's past.
It just looks like a simple sequence, a straight line of things happening one after the other over billions of years.
But here's where it gets really, really strange. When geophysicists actually analyzed the timing between these major events, the boundaries between the eras, they discovered they aren't random at all, not even close. There's a hidden mathematical structure, a secret rhythm embedded in the entire timeline.
And that structure is something called a multifractal. It's a kind of pattern that shows the same kind of complexity at every scale you look at it. The absolute perfect example is a coastline. Think about its jagged, irregular shape. It looks just as complex and chaotic from a satellite in space as it does when you're standing right there on the beach a few feet away. That's a fractal.
Now, just stop and think about what that implies for a second. If the geological timeline has this complex, repeating mathematical structure, it suggests that time itself isn't just a simple straight line moving forward. It suggests that time has a shape, a measurable geometry, which is exactly what you would expect if it were a shadow being cast by some higher dimensional object.
So now we have these two completely different clues. We've got a chemical fingerprint from a single asteroid impact, and we've got a mind-bending mathematical pattern that spans billions of years. So let's put it all together and see how these two totally different lines of evidence actually point to the exact same wild conclusion.
Okay, this table really lays it all out. The theory predicted it needed to find a slice invariant, a property of the 4D source. Boom, geology gives us the 17 to 25% asteroid mix. The theory predicted a foliation artifact, a signature from the 3D process unfolding over time. Boom, geology gives us the magnesium isotope signature. And finally, the theory implied that time itself has to have some kind of geometry. Boom, geophysics finds the multifractal pattern hidden in the timeline. Check, check, and check.
So the crucial takeaway is this. We have solid evidence from two completely separate fields of science, geochemistry and geophysics, that both independently point to the exact structures predicted by this radical framework. This isn't just a lucky guess or a coincidence. This is the kind of powerful, independent validation that makes a scientific theory really stand out.
So this brings us to the really big picture. What does it all mean if they're right? What are the implications if time is just a feature of geometry and our entire reality is just a projection from somewhere else?
And this right here is probably the most important part. This isn't just a fun, mind-bending philosophical idea to think about. It's a real scientific framework because it makes concrete, testable predictions. Predictions that other scientists can go out and try to prove wrong. That's the hallmark of good science.
For instance, the framework predicts that the 17 to 25% ratio shouldn't be a one-off. It should be a stable value we can find in other major asteroid impacts throughout history. It predicts that the same multifractal pattern we see in geology should also show up in the timing of major evolutionary events, like the Cambrian explosion. It even makes predictions about basic chemistry. And these are all things we can now go out and test. And all of this leaves us with one final, fascinating question. If the evidence from our own planet's deep past really is pointing towards something this profound, it just makes you wonder, what other fundamental parts of our reality, things we take for granted every single day, like time itself, are maybe just shadows of a deeper, more complex, and ultimately timeless truth?